Today we will start new topic, that is application of definite integration, uh, in which we are going to learn area under the curve. So basically in this chapter we will study area under the curve. In this there are two topics: area bounded by the curves, the axis and the given lines. Then it may be bounded by x-axis or it may be bounded by y-axis. Then we will learn the area between the two curves. So already we have studied in a previous chapter that we are finding the integrations, means we are finding the actual area under that curve, that is limit of sum. We have evaluated the integrals using limit of sum. So geometrically this integration a to b f of x dx gives area under the curve y is equal to f of x with f of x is greater than 0, bounded by the axis and the lines x is equal to a to x is equal to b. That is integration from a to b f of x dx is phi of b minus phi of a. This is just a fundamental theorem of integral calculus. Now, what is this area under the curve? For evaluation of area bounded by certain curves, we need to know the nature of the curves and their graphs. We should also be able to draw the sketch of this curve. Whatever problems you have given, you must be able to draw the rough sketch of that particular curve so that you can find its area. The curve y is equal to f of x is a continuous in closed interval ab. Whatever curve area under the curve we are going to find, that curve must be continuous on the given interval. It should not be discontinuous, otherwise we are not able to find the area under the curve. Then there are two formulas. The first one is the area bounded by the curve y is equal to f of x and x-axis, the lines x is equal to a and x is equal to b, is given by a integration from x is equal to a to x is equal to b y dx, y into dx. Whenever the area is bounded by x-axis, then we will use this formula integration y dx. And the second one is whenever the area is bounded by y-axis, so the area bounded by the curve x is equal to g of y and the y-axis. So the limits are y is equal to c to y is equal to d. In this case, we will use the formula x dy. So integration from y is equal to c to y is equal to d x dy. So whenever the area is bounded by x-axis, we will use the formula integration y dx. Whenever the area is bounded by y-axis, we will use the formula integration x dy. Now find the area bounded by the curve y is equal to x square and the y-axis and the x-axis and the line x is equal to 3. So first of all we must have the idea of its graph. Y is equal to x square. So that is x square is equal to y. So it is the parabola opening towards a positive direction of y-axis. Okay, this is the graph of the parabola. Then we will draw the line x is equal to 3. So this is the actual area that we want to find. Once we know the nature of the area, it is clearly bounded by the x-axis, okay, bounded by the curve and bounded by the line. So we have to integrate from 0 to 3 by taking this y for the upper curve. So the area is given by x is equal to a to x is equal to b y dx. What is y? Y is for upper curve. This is the curve by which bounds the area. So y is equal to x square. So 0 to 3 x square dx, its integral is x cube upon 3, lower limit and upper limit. So put upper limit minus lower limit, so you will get 9 minus 0, that is 9 square units. This is the area of the, this is the area that we want to find out. Now let us learn how to find the area between the two curves. Suppose y is equal to f of x and y is equal to g of x are the two equations of the curves, and then we want to find the area between these two curves. Now we have learned that after taking this y. These are these are our limits. X is equal to a to x is equal to b. So we have to integrate between these two. And as this area is bounded by this x-axis, so if you take this y, you will get all the area which lies below this. Okay, and if you take this y, then you will get the area which lies between, like below this. So in either case we are getting more area, but we want only the area which includes between these two curves. For that, what we will do, we will subtract the second area from the first area, so that what will remain, we will remain only this shaded region. This is the shaded region, that area we want to find out. So for this, we will, what we will do, we will subtract the second area from the first area. So what is a1? A1 is the area bounded by the curve y is equal to f of x, x-axis, and the lines x is equal to a to x is equal to b. And a2 is the area bounded by the curve y is equal to g of x, and the lines x is equal to a, x is equal to b, and x-axis. So the now the point of intersection of these two curves also we have to find out by using simultaneous equations. So we will solve these two equations simultaneously, and we will obtain the point of intersection of these two curves. Look at this example. Find the area of the region bounded by the curves y square is equal to 9x and x square is equal to 9y. Now y square is equal to 9x is the equation of the parabola opening towards positive direction of x-axis. X square is equal to 9y is the equation of the parabola opening towards positive direction of y-axis. So these are the curves and these are their graphs. Okay, so this is the area between these two curves. Okay, that we want to find out, but we don't know from where to where we have to integrate. So we have to solve these two equations simultaneously. हे दोन इक्वेशन्स आपल्याला सायमल्टेनियसली सोडवावे लागतील. मग एक्स एस टू 4 ह्या दुसऱ्या इक्वेशनचा स्क्वेअर करा, then use this y square in this equation and then simplify. You will get x is equal to 0, or x cube minus 9 cube is equal to 0. That means x is equal to 0 or x is equal to 9. If you put x is equal to 0 in this equation, you will get y is equal to 0. And if you put x is equal to 9 in this equation, again you will get y is equal to 9. So the points of intersection you are getting is 0, 0, 9, 9. These are the point of intersection of the curves. So we have to integrate from 0 to 9. We have to integrate from 0 to 9. Now this is for upper curve. So what is y for this upper curve? It is y square is equal to 9x. So what is y? Y is root 9x. So root 9x. And y for the lower curve? Y for the lower curve is x square upon 9. So 0 to 9 x square upon 9 dx. Now its integral is root 9, its square root is 3. So 3 into root x can be written as x raised to 1 by 2, and its integral is 2 by 3 x raised to 3 by 2. Lower limit, upper limit, minus 1 upon 9 we can take outside. Then integration of x square is x cube upon 3, lower limit, upper limit. So if you simplify this, you will get the required area as 27 square units. Now we will learn what will happen if the f of x is less than or equal to 0 in the given interval, that is f of x attains the negative values. Then what will happen? Find the area bounded by the curve y is equal to minus x square, x-axis, and the lines x is equal to 1 to x is equal to 4. Now let A be the area bounded by the curve y is equal to minus x square, x-axis 1 to 4. X lies between 1 to 4. So this is the parabola. Y is equal to minus x square means it's x square is equal to minus y. So this is the equation of the parabola which open towards negative direction of y-axis. And the limits of x are given. X is equal to 1 Look at here, x is equal to 1 to x is equal to 4. Now this part lies below this x-axis, so this area will be negative, and we want to find this area. Again, this is the bounded by x-axis, so we will use the first formula y dx. So integration from x is equal to 8, x is equal to b, y dx. What is y? Y is minus x square. Take its integral, minus x cube upon 3. Lower limit, upper limit. Simplify it, we will get minus 21. But the area is never negative, it is always positive. So A is equal to 21 square units. Now, if so, here, if the value of the function is negative in the given interval, you will get the area negative. But area is never negative, so we will always take the area to be positive. Again, we may arise or face the cases like this, to find the area between the bounded by x-axis between the two lines. X is equal to 8, x is equal to b. The part of the area lies below the x-axis and some part of the area lies above the x-axis. Then uh, you may get trouble in solving these such type of examples. So how to solve these examples? We will make two parts of these areas, the a part which lies below the x-axis and the part which lies above the x-axis. Then we will find this area, then we will take its magnitude because area is never negative. Then we will find the area which lies above the y-axis. So we have to integrate from x is equal to a to t, and then t to b, like this. We will take the sum of these two areas by taking the modulus a to t f of x dx plus t to b f of x dx. Now find the area bounded by the line y is equal to x, x-axis, and the lines x is equal to -1 and x is equal to 4. Consider the area A bounded by the straight line y is equal to x. Suppose this is the line y is equal to x, and which is also bounded by the x-axis. So, and the lines x is equal to -1 and x is equal to 4. So this is the line y is equal to x, and we want area between the lines. This is your, okay, this is your -1 and this is your +4. We want to find the area between these two lines. So we cannot directly integrate from -1 to +4. So we have to, first of all we will find this in this area -1 to 0, and then we will find this area 0 to 4. So first of all we will find a1 -1 to 0. Its area is -1 upon 2, but area is never negative, area is always positive, so we will take its modulus, so that a1 is equal to 1 upon 2 square units. Then we will go for a2. The area lies in the first quadrant. 0 to 4 y dx is 0 to 4x dx. So take its integral and find the area, 8 square units. Then we will take addition of these two areas. 17 upon 2 square units is the required area. The next example is find the area enclosed between the x-axis and the curve y is equal to sin x for values of x between 0 to 2 pi. Now, the area enclosed between the curves and the x-axis consists of two equal area lies alternately above and below the x-axis, which are respectively positive and negative. Okay, sine of x. This is the curve sine x. Okay, so and we want to find area between 0 to 2 pi. So 0, this is pi by 2, this is pi, this is 3 pi by 2, then 2 pi. So the first area A1 is lying above the x-axis. So we will integrate between 0 to pi. 0 to pi upper limit, and the y for the upper curve is sin x. So 0 to pi sin x. Sin x, its integral is minus cos x. Lower limit, upper limit. Find its value, you will get 2. Similarly, go for the negative area lying below the x-axis, pi to 2 pi sine x. Again integrate with respect to x and then put lower limit and upper limit, you will get a2 as minus 2. So the total area is a1 plus modulus of a2, that is 2 plus 2 is 4 square units. So this is the actual area of this the curve bound sin x bounded by x-axis between the two lines, x is equal to 0 to x is equal to 2 pi. Now this is the activity for you. You have to find the area bounded enclosed between the curve y is equal to sin x, the x-axis and the lines 0 to 4 pi, the first activity. Then in second activity we have to check the function cos x. Okay, the area bit bounded or enclosed by the curve y is equal to cos x and the x-axis between the limits. First problem is 0 to pi by 2, then second one is pi by 2 to pi, and the third one is 0 to pi. We have to find all these limits. Okay, then we will stop here now.